Good morning, gentlemen. Hope your day is going well today. I'm going to give a presentation today. We're going to be moving into ELW 231 electrical power systems. We did the substation presentation before that you guys made, and we're going to go more in depth as far as the circuitry in the substation, plus the protective devices that you have out there on the circuits. And you will be doing another presentation again for substation and line protection, but that's not going to happen today. That's going to be posted tomorrow. So we're going to talk today about substation circuit breakers and how they operate, what they are. Firstly, how do I identify that I have a substation circuit breaker and what type is it? I've got some different pictures that I'll show you along here through the course of it, and actually go into how the relays and everything works. So my first one here is, how do I identify that it's a breaker? Well, the simple way of doing that is if you have bushings that are the same size on both sides of it. This is 1, 2, 3 on the input, kind of blocked here, but in the picture is 1, 2, and 3 on the output, and they are the same size, then you know it's a breaker. There's no transformation going on inside this. This is just opening and closing as designed. Another picture you have here. This one's kind of cool. Found this one on the internet. This breaker actually blew up and blew out the side of it. You can see where the fire, and this is actually white. It got so hot in this area right here. But you notice on the top, bushings on both sides are the same. They've got it disconnected and getting ready to replace it. Same here. This gentleman's at it, and you'll notice inbound and outbound. Now these are mounted a little bit differently. They're on sideways, but still it's inbound and outbound. And these guys are actually doing an install on a circuit breaker in a substation, and you'll notice again, in and out, same size. So good question would be there, how do I identify? Bushings are same size, both sides. Good identification method. All right, there are some out there, but they're very rare. All breakers are 3-phase. Okay. All open or all close at the same time. And you know I've got keyboard dyslexia, so just keep up with me. So if I have a fault on one phase, all 3 phases are going to open, and it doesn't matter which one it is in that process. So that's a good identification method, plain and simple. What's their purpose? Well, typically you won't find any of these on tap lines. Tap lines, we use a fuse. So that's the purpose of protection that we have out there on the tap line. A breaker's purpose is to, and there are multiple ones, protect the feeder from damage. We just don't want anything, no protection out there. And if our feeder gets wrapped up in a tree or another line or falls to the ground, we just don't want it to burn forever and damage our equipment. All right, protect. Again, if it falls on something or falls to the ground, we need that circuit or wire to be de-energized as quickly as possible so the public doesn't come around and have an energized circuit. And lastly, protect the substation. Definitely don't want that fault to go back into the substation and then back to the substation transformer, and our next protective device would be the ACI. So it's a little bit of protect the substation and the transformer, line isolation. So if that breaker opens, the rest of the breakers can keep on going in the substation, and I've isolated that feeder circuit. And then I'll have to effect repairs. So the purpose: protect the feeder from damage, protect the public, protect the substation, and line isolation. How they work. You probably have to go back to your notes a little bit on this one and check it out. Each one of these, and I put up a distribution one to just let you know. I'm just going to go ahead and put my mouse over these areas right here. See if you remember. One side, I have one on this phase, one on this phase, and one on this phase. Look at this next picture. You can't see it on top of the bushing, but it is built into the breaker. You'll see one right here, circling it with my mouse. Alright, this one's covered, but it is inside the breaker, just as you saw in the previous picture before. It's taking a measurement. Here they're mounted. In this situation, this is kind of different right here. There's actually two of them. One's normal operation and one's a backup. And this we'll get to in just a moment. Alright, so if you don't remember, need a little hint here. These are current transformers. Alright, to be able to get a signal from the primary going in and out, or take a measurement of the primary going in and out of how many amps there are in and out, I need to transform that current from a high current level to a lower current level, so I'm able to take a reading on it. So that's what these are, current transformers. I'm transforming a very high current that's on the primary or transmission circuit, and I'm transforming it to a much lower one, and after it leaves here and is transformed, it goes into this panel. There I'm able to use that low current on a much smaller wire, take readings off of it, and be able to open and close relays, and eventually open and close the breaker itself. So that's the purpose right there. There's one. You can't see it here. This typically goes, you see this pipe right here. I'm taking CT readings out of the breaker, and you see this pipe that's going up to the left hand side. That's going to my relay panel. So that's all my low current, transformed current data that's going to the relay. Can't see it in this one. This one isn't even wired yet, so they're not taking it to the relay panel yet. And this is the actual relay panel. This can be inside the substation, inside a substation house or enclosure, or it could be right inside the breaker. The picture that you're seeing right here is in a substation house complex. Alright, how do they work? They get amp readings from CTs and open/close based on circuit status. Alright, so if the circuit is all good, everything's going fine, I'm still getting amp readings from the CTs, but they're all in the normal range. So the circuit status is good, the breaker doesn't have to do anything. If the circuit is faulted or overloaded, and we'll talk about the difference in those in just a bit, then the CT is going to send the signal to the, or it's going to send the amp reading to the relay, and it's going to tell the breaker to open. All right, CTs do not tell the breaker to close. They just tell the breaker to open. They're just giving a reading. All right. Remember, automated. This is all happening without human intervention. Now you can take control, and we'll talk about that in just a moment, of the breaker. So you can do functions inside of it, opening it and closing it. But as far as an entry alignment is concerned, they're automated, and there's no further than you need to go as far as that is concerned, unless you need to open a breaker. Okay? You as a lineman can open only. All right. So let's go to the breaker relay panel. You're going to see in this panel, this looks like a lot of stuff that's going on here. Firstly, there are two types. There's electromechanical, what you're looking at right here, and digital. Let me bring one up. You see there's a multiple variety. You've got a distribution reclosing relay, a feeder protection relay, just multiple types. What you're seeing right here, and I'll show you the ones that are most prevalent out there in the world, are these types for distribution. If you're going into transmission, we'll talk about the difference between the two in just a moment. You see a different, little bit of different type, but this is all there is. Where you saw in this picture all these relays and all this stuff right here, now electromechanical. So I need an electrical system to open and close an actual relay. The new generation here is digital. Let me get another picture going on here. I want you guys to see the screen that's over to the side. Looking at this one, you can actually see, and you know, if you walk into a substation and if you're asked any questions as far as it's concerned, your dispatchers on a phone or radio are going to be able to tell you a whole lot of information of what you need to check. Remember, and this is the simple one, this is the state it stays in all the time unless you tell it to do something different on the meter. Right here it is I. What does I stand for? Current. So the current on A phase right now is 0. The current on B phase is 0, the current on C phase is 0, and the current on neutral is 0 also. So they're pretty easy to read. It'll tell you actually here if you had a fault on A, B, or C, or neutral. We'll talk how you can get a fault on neutral here in just a little bit. But they're pretty easy to read, and like I say, ask questions. If you got somebody that says, well, what is the current reading on A? That's pretty simplistic. Do you have a fault on B? That red light will be up. Are you in local or remote? So there's a lot of different stuff that you can ask questions about as far as that's concerned if you are asked to go into substation and check something out. The full scope here, guys, is if you're working out there in trouble call in the field, one, I want you to be able to identify things out there in the field, and two is be safe. So there's a lot of safety features that are going on here in this process. All right, my phone just rang. Can I call you back? Okay, all right, appreciate it. Bye. All right, that was the boss man. You gotta answer him all the time. All right, so back to the relay panel. And we're going to start electromechanical first. Okay, so the actual function, now I've got my breaker that's over here. I'm getting transform current that goes to a control panel. Well, this is the control panel that you're looking at right here, and I have electromechanical relays. So don't concern yourself with what you see up here. This is the stuff that you have to identify, and I know probably from this video that you can't see these things very well, but they are labeled. 1, 2, 3, 4, and 5, and we'll discuss what these are in just a moment. All right, so Electromechanical relay breaker. Okay, so here we go with the attributes. First, the ones that you need to be concerned with as an entry lineman are, there are how many total? Well, how many phases do I have? A, and this is labeled A, B, relay, C, relay, ground relay, and this one right over here to the side is what they call a reclosing relay. So how many relays do I have total for a distribution breaker? 1, 2, 3, 4, and 5. 5 total relays. Phase relays. Ground relay. And reclosing. I hear Robbie calling me on Zoom. Yes, I am, and I'm doing a video for the tomorrow's work. Okay. All right. 5 total relays: phase relay, ground relay, and reclosing. Let's talk about their individual purpose. Phase relays. They detect the fault on each phase. Okay, so if I have an A relay, it's only detecting a fault on A. If I have a B relay, only on B. And if I have a C relay, only on C. Remember though, up here, all breakers are 3-phase, all open or all closed at the same time. So if I come back down here and talk about my panel, and I have a fault on C phase, it's going to send a signal to the breaker to open all 3 phases. Ground relay. You wouldn't say that it actually detects a fault. It does detect amperage and overload. Okay, we'll talk more about fault and overload in just a minute. All right. Back here to the photograph. And the reclosing relay. Well, the reclosing relay is exactly what the word says. Recloses breaker. I had dyslexia. E-A-K-E-R. Alright, so 5 total relays: phase relay, ground relay, and reclosing. Phase relays detect a fault on each phase. Big one, open only. Alright, the phase relays only open the breaker. That's all they do. The ground relay is the same. Only open. So it takes another relay to reclose the breaker. Right, back to our photograph right here. Okay. Phase A, B, C, they send a signal to the breaker to open. Ground can also send a signal to the breaker to open. Reclosing relay right here, that one recloses the breaker back. All right, so we're pretty much here in identification. There's 2 more things I'm going to put on the video right here. As far as this is concerned, this part, I'm going to do another part to get a little bit more in depth. I'm going to do the overload and fault situations here in this video also. So what's left on the breaker for you to be concerned with as a new lineman? Alright, over here to the left hand side, and they can be labeled different, but typically this one is the middle right here. I have a handle, open and close. Open and closes the breaker. Right. Here's a simple way of knowing where you at in the status as far as the handle is concerned. Red equals hot. Green equals dead. And I like to kind of do this one too. And go. That means you can go to work and it's de-energized. Red hot, green dead, and go. And you'll notice that in the photograph right here. It's kind of hard to tell. Green, white, and red. We'll talk about the white here in just a moment. That means it's in operation. It's doing a function. So we'll add that right here. White. Doing something. It's automated. Remember, it's actually in the process of opening, closing, or doing whatever it is in its automated state. All right. For the rest of this video right here, we're just going to go into the, like I told you before, we're going to discuss what a overload is and what a fault is. Simply, fault. Now this is a situation where the phase falls to the ground, or the phase bumps into another phase, or the phase, a tree falls into it. These are all some types of fault conditions that you may run into out there in the world. The attributes of the fault itself concerning the breaker, it's very high amperage. Sometimes between 10 to 50,000 amps. This is extreme. When we have a fault on our phase out there and the relay recognizes that fault to be in this situation, it's going to send an open signal to remember, phase relays only open the breaker. I think I hit one too many. Nope. Overload. Now, the situation is going to be the same almost. Instead of a very high amperage, 10 to 15,000 amps, my amps go over relay, breaker, rating. So if I have a breaker that per phase does 600 amps, and that's what it's designed for, and for some reason on my circuit, say it's a real hot summer day or it's a real cold winter night, and that amperage starts raising and this goes to 650 amps, well, the relay's got to recognize that. I, one, don't want to damage my breaker, and two is my conductor and circuit out there, as far as this breaker and this circuit is concerned, I don't want to damage that either. So breaker will open. All right. And this is dependent on the company and what they do in situations. They'll have a certain percentage set for the relay. You can adjust the relay. And if they want to get real tight and say, well, it's rated for 600, I want it to send an open signal at 610, then they'll do that. Or I've got it rated at 600 and I actually feel comfortable with going to 700. That's all in their design as far as their circuit and breaker relay is concerned. That's completely up to them. But as far as the two different conditions here, fault, very high amperage, 10 to 15,000 amps, very quick. This happens in an instant. That's a fault explanation. Overload, on the other hand, is something that just builds. The circuit amperage starts to go up, and it goes over the relay and breaker rating. And this is just an example of numbers right here, and the breaker will open. Okay, so that's the video for now. I will be putting more videos out, at least one more video out concerning breakers and substations, and you'll have one quiz for all videos. So I'm not going to bust out multiple quizzes in this situation. Okay, gentlemen, hope everybody does well today, and I thank you very much for watching. Have a good